Hello everyone. I hope you all are doing good in your academic. Today we are going to do graded assignment of week 5 of Stats 2. As you all might have already seen that graded assignment of week 5 for Stats 2 contain 20 question. So we will cover 10 question in this video and 10 in later video. In this video we will discuss from question number 1 to question number 10. So without wasting any further time, let us just jump on the first question. The first question basically says that a person randomly choose a battery from a store which has 140 battery of type A and 380 battery of type B. Battery life of type A and type B are exponentially distributed with average life of 14 years and 19 years respectively. If the chosen battery lasts for 5 years, what is the probability that the battery is of type A? So there are 140 batteries of type A and 380 batteries of type B. X follow exponential distribution with lambda is equal to 14 and Y also follow the exponential distribution with lambda is equal to 19. Let us assume L is equal to a battery last 5 years. Then basically we have to calculate what is the probability of A under the condition L. So first of all, let us calculate that probability of each battery. Since there are 140 and 380 batteries, so the total battery is going to be 140 plus 380, which is 520. Now the probability of choosing battery A is equal to 140 by 520, which is 7 by 26. And the probability of choosing battery B is equal to 380 by 520, which is 19 by 26. It is given that both X and Y follow the exponential distribution. We know that probability of t greater than t in exponential distribution is given by e to the power minus t by lambda. So the probability of L under the condition A is equal to e to the power minus 5 by 14, and probability of L under the condition B is equal to e to the power minus 5 by 19. Now we need to find probability of A under the condition L. So let us use Bayes' theorem on it. Then as per Bayes' theorem, probability of A under the condition L is equal to probability of A into probability of L under the condition A by probability of L under the condition A into probability of A plus probability of L under the condition B into probability of B. Now we already find the values for each probability that are required, so let us now put the values in the Bayes' theorem. After doing all the calculation or factorization, the probability that we will obtain is probability of A under the condition L is equal to 1 by 1 plus 2 times exponential of 5000 by 53,200, which is same as option 4. If you feel any trouble in solving the equation, then you can pause the video and see my steps, and still if you can't figure out, then reach me in comment box. Hence the option 4 is going to be the correct option for the question number 1. Let us now move towards the question number 2. Question number 2 says that let y is equal to x times z plus x, where x follow uniform over the range 1, 2 and 3 and z follow normal with 1 and 4 as its parameter. We need to find the probability of f of x of 2 under the condition y is equal to. First of all, let us see the things that are given in the question and what we are asked to do. Given x follow uniform over the range 1, 2 and 3. Z follow normal with the mean value is equal to 1 and the variance is equal to 4. Y is equal to x times z plus x and they are independent. Now we are asked to find the probability of x is equal to 2 under the condition y is equal to 2. So, let us elaborate the f of x is equal to 2 under the condition y is equal to 2 using the Bayes' theorem. F of x is equal to 2 under the condition y is equal to 2 will equal to f of y of 2 under the condition x is equal to 2 into probability of x is equal to 2 by probability of y is equal to 2. If we look at probability of y is equal to 2, then it is clear that since y depend upon x and x take 3 values, so the probability of y is equal to will be going to something look like summation of f of y equal to 2 under the condition x is equal to x into probability of x is equal to x, where x will varies from 1 to 3. So now our f of x equal to 2 under the condition y equal to 2 will be look like f of y equal to 2 under the condition x equal to 2 into probability of x equal to 2 by summation over x equal to 1 to 3 of f of y equal to 2 under the condition x equal to x into probability of x equal to x. P of x will cancel out each other from numerator and denominator part. After which our f of x equal to 2 under the condition y equal to will be f of y equal to 2 under the condition x equal to 2 by Summation over x is equal to 1 to 3 of f of y is equal to 2 under the condition x is equal to x. Given y is equal to x times z plus x. So y will be equal to x times whole of z plus 1. Since z follow normal with 1 and 4 as its parameter. So z plus 1 is also going to follow normal with 2 and 4 as its parameter. From this we can find that y equal to 2 under the condition x equal to x will follow normal with a into nu and a square into sigma square as its parameter. For example, y is equal to 2 under the condition x is equal to 1 follow the normal 2 and 4 as its parameter. Now since all these f of y follow normal, we will use Gaussian PDF to find its PDF. So as per the Gaussian theorem f of y is equal to 1 by root under 2 pi sigma into exponential of minus y minus nu to the whole square by 2 times sigma square. So if we solve the each f of y using Gaussian PDF, we will get our probability of y is equal to 2 by summing these three values. So our f of y is equal to 2 under the condition x is equal to 1 is 1 by 2 root 2 pi. Our f of y is equal to 2 under the condition x is equal to 2 is equal to 1 by 4 root 2 pi into exponential of minus 1 by 8. And our f of y is equal to 2 under the condition x3 is equal to 1 by 6 root 2 pi into exponential of minus 2 by 9. Now let us put all these value in our f of x equal to 2 under the condition y is equal to 2 and it will be something look like this one. Now if we solve this by taking 1 by 2 root 2 pi outside and cancelling it from both numerator and denominator and later multiplied by 6, then what we will get is 3 times exponential minus 1 by 8 by 6 plus 3 times exponential minus 1 by 8 plus 2 times exponential minus 2 by 9. Hence the option B is correct. Again, if you feel any trouble in solving this, then you can pause the video and see mine calculations. Now let us see the question number 3. Question number 3 says that x is a continuous random variable and its PDF is given below. We need to find the PDF of y is equal to 1 minus 7 to the power 7. Now we know that to find PDF of function of x where PDF of x is given, what we can do is f of y is equal to fx of x prime into modulus of differentiation of x prime with respect to dy, where x prime means writing inverse of inverse. Given y is equal to 1 minus x to the power 7. So if we make its inverse, then it will be x is equal to 1 minus y to the power 1 by 7. Now if we find fx of x prime by putting x prime in place of x and f of x, then what we will get is 6 times y to the power 5 by 7. Now let us find the derivative of x prime with respect to dy. After solving its derivative, what we will get is y to the power minus 6 by 7 by 7. Now we know that fy of y is equal to fx of x prime into modulus of derivative of x prime with respect to dy. After putting its values, the fy of y that we get is 6y to the power minus 1 by 7 by 7. Hence, let us now see the question number 4. Question number 4 is again the same question that we just did. Here again a continuous random variable is given with its probability density function, and a function of this continuous random variable is also given, and we have to find its PDF, or we have to find the probability density function of y. So let us find the g inverse x, or write x in terms of y. Y is given as 1 by 3 into 27 minus x. So x will be equal to 27 minus 3 times y. Now, let us find the derivative of x prime with respect to dy. If we solve derivative, then we will get is 3. Now let us find fx of x prime, which is going to be equal to 27 minus 3 times y whole to the power 2 divided by 81. Now if we multiply both values, then we will get fy of y, which is basically 3 times 27 minus 3 times y to the power 2 divided by 81. Hence the option C is correct for question number 4. Now let us move toward the question number 5. Question number 5 basically says that let x be a continuous random variable where the probability density function is given below, and we are asked to find the 65 times of expectation of x. We know that to find expectation of a continuous random variable by using its probability density function, what we basically have to do is we have to integrate that probability density function x times with respect to dx over its interval. So let us do the integration. It is basically integrating x into x to the power 4 plus 6 times x minus 5 with respect to dx over the interval 0 to 1. So after solving this integration, the expectation of x that we are going to get is 0.8988. Hence, 65 times expectation of x is equal to 65 into 0 by 8988, which is equal to 58.42. Hence the answer of question number 5 is 58.42. Now let us see the question number 6. Question number 6 says that x is a continuous random variable and its probability density function is given below, and we are asked to find the variance of y where y is given as 48 times x plus 5. We know that if y is equal to a times x plus b, then variance of y is basically equal to a square into variance of x. So here variance of y become 48 square into variance of x. And we also know that variance of x is basically equal to expectation of x square minus expectation of x to the whole square. So first let us find the expectation of x. Since fx is distributed in two intervals, so we have to find the expectation in both interval and then have to add them to find the expectation of x. Expectation of x here will be something look like integrating x into dx over the interval 0 to 1 plus integrating x into 2 x into dx over the interval 1 to 2. Now if we solve this integration, then the expectation of x will be equal to 1. If you feel any trouble in solving it, you can pause the video and see the calculation. Now let us find the expectation of x square. To find the expectation of a function of y, what we have to do is we have to multiply fx with function. Just like in normal expectation of x, we multiply fx with x, here we will multiply fx with function. So now expectation of x square will be something look like integrating x square into dx over the interval 0 to 1 plus integrating x square into 2 minus x into dx over the interval 1 to 2. Now if we solve this integration, then the expected value of x square will be equal to 7 by 6. Hence variance of x is equal to 7 by 6 minus 1 square, which is equal to 1 by 6. Now variance of y is equal to 48 square into 1 by 6, which is equal to 384. Hence the variance of y is going to be 384. Let us now see the question number 7. Question number 7 says that suppose x follow normal with the parameter 3 and 4. Y is equal to 2 times x plus 9. Since it is given that x follow normal distribution and y is depend upon x only, hence y will also going to follow the normal distribution where mean will be equal to a nu plus b and variance will be a square sigma square. Since y is equal to 2 times x plus 9, means is equal to 2 and d is equal to 9. So y follow normal distribution with mean value is equal to 15 and variance as 16. Now we know that Gaussian probability density function is used to find the fy of y where y follow normal distribution. So if we solve the Gaussian PDF, then fy of y is equal to 1 by root under 32 pi into exponential of minus y minus 15 square by 32. It is equivalent to option C. Hence option C is the correct option for question number 7. Let us now see the question number 8. Question number 8 says that suppose x is equal to continuous random variable with mean 50 and variance is equal to 16. Using Chebyshev inequality, find the greatest lower bound of the probability that x takes a value in between 1942 and 1958. Okay, so first of all, let us see what are the things that are given in this question. We are provided with mean value which is 50, we are provided with variance which is 16, and we are also provided with the range which is 42 to 58. So, this is the basic formula of Chebyshev inequality. Let us first find the k here, which we solve, then we get that k is equal to 2. Now if we find the probability of x minus 50 less than 8, then it will be greater than or equal to 1 minus 1 by k square, which result in 3 by 4, which is 0.75. Hence the answer of question number 8 is 0.7. Let us now see the question number 9. Question number 9 says that a passenger train arrives punctually at a station every 20 minutes. Each morning, a passenger walks into the train station. Let x denote the amount of time in minutes the passenger waits for the train from the time he reaches the train station. It is known that the probability density function of x is given. A function of x is also given below, which is y is equal to x cubed plus 22, and we have to find the expectation of y. So it is given that x is the amount of time in minutes that a passenger have to wait to get a train. Means that the range of x is going to be 0 to 20, 0 when a passenger just arrived when a train arrived, and 20 when a passenger arrived just after a train departed. Hence x is going to follow the uniform distribution over the range 0 to 20. We know that if y is equal to a times x plus c, where x is a random variable, then expectation of y will be equal to a times expectation of x plus c. So here expectation of y become expectation of x cube plus 22. And we just see how to find the expectation of a function of a random variable, where we basically have to integrate that function multiply by the PDF of the random variable with respect to dx over its interval. So expectation of x cube will be something look like integrating x cube by 30 with respect to dx over the interval 0 to 20. If we later solve this integration, then the expectation of x cube that we are going to get is 2000. Again, if you feel any problem in solving the integration, then you can pause the video and see the calculation part. As we find expectation of y is equal to expectation of x cube plus 22. So here expectation of y become 2000 plus 22, which is 2022. Hence the expectation of y is 2022. Let us now see the question number 10. 60% of the total people in a city were male and 40% were female. The age of the males is normal with parameters 60 and 25, and the age of the females is normal with parameter 55 and 36. If the age of a randomly selected person is 60, what is the probability that the selected candidate is male? So it is given that probability of male is 0.6 and probability of female is 0.4. M follow the normal distribution with the parameters 60 and 25, and F follow the normal distribution with the parameter 55 and 36. We are asked to find probability of male under the condition age is equal to 60. Again, let us use Bayes' theorem to simplify this conditional probability. So if we use Bayes' theorem on this conditional probability, then probability of male under the condition x is equal to 60 will be something look like probability of x is equal to 60 under the condition it is male into probability of male by probability of x is equal 60 under the condition it is male into probability of male plus probability of x is equal 60 under the condition it is female into probability of female. We already did many questions of this type where the distribution follow the normal distribution, and we have to find its PDF using the Gaussian PDF, and later we have to put the values in the Bayes' theorem to get our desirable answer. Again, we have to do the same thing here. We first use Gaussian probability density function to find the each conditional probability and then substitute each required value in Bayes' equation to get the required answer. So if we find the probability of x is equal to 60 under the condition it is male using the Gaussian probability density function, then the probability we will get is 1 by 5 into root under 2 pi, as it follow the normal distribution. Similarly, probability of x is equal to 60 under the condition it is female is equal to 1 by 6 root under 2 pi into exponential minus 25 by 72. Now we have the probability of female, probability of male, probability of x is equal to 60 under the condition it is male, and have also the probability of x is equal 60 under the condition it is female. So now let us put all this value in the Bayes equation to find the probability of male under the condition x is equal to 60. So if we solve the equation with some factorization, then the probability of male under the condition x is equal to 60 will be equal to 9 by 9 plus 5 times exponential of minus 25 by 72, which is equal to option C. Again, if you face any problem in calculation part, you can post a video and see my calculations, and still if you can't figure out, then you can reach me in the comment box. Hence the correct option for the question number 10 is option C. Okay, so that is it for the part 1 video of graded assignment of Stats 2, where we cover the questions from 1 to 10. Remaining question we will cover in part 2.